Hey, Ishnu. Should be good to start whenever you're ready. And you should also have the ability to share your screen. So just keep that in mind. And thank you so much for hosting. We really appreciate it.
Perfect, no problem. I'll get set up in just 1 second.
Sounds good.
All right. So, hello everyone. Welcome to the Intro to AI workshop hosted by AppDev League. My name is Aishin Suresh, and I'm more than honored to be hosting this workshop. I'm a part of the organization by the name of App Development League. And AppDev League is just a student-run organization focused on supporting educational programming content for students. And founded in 2019, we are a 501c3 nonprofit devoted to bring modern web and app development opportunities to underrepresented students. We strive to empower students, regardless of their socioeconomic status or racial background, to make a social impact through the power of apps. So, you guys are all here today in order to learn more about AI. So let's dig more into it. Please let me know if you can see my screen. All right, I see a thumbs up in the chat. I think should be good. So once again, to everyone who's just joining, welcome to the Intro to AI workshop. My name is Aishin Suresh, and let's begin. So what is artificial intelligence? Well, artificial intelligence is a broad topic. However, it can be explained as the expansive field covering disciplines ranging from computer vision all the way to machine learning. What artificial intelligence does is that it aims to simulate parts of human intelligence in computers. And there are a variety of applications within the artificial intelligence field. Applications such as medicine, finance, hospitality, and many more. Now, some modern examples of artificial intelligence include Google Assistant, self-driving cars from, say, Tesla, or some player versus computer games, and many more. Artificial intelligence has continued to be a prevalent aspect of our daily lives, and this is only just the beginning. So you may be wondering, what language do you use to code for artificial intelligence tasks? Well, the most popular in the industry is Python. Now, why is Python useful for AI? Well, Python uses less code, has pre-built libraries for the artificial intelligence space, has massive community support. It's easy to learn because the syntax is extremely similar to the English language, and you can easily visualize your code as well. So, what is machine learning? So machine learning is in fact a subfield of artificial intelligence, and machines learn to complete some tasks without being explicitly programmed for that task. So say instead of hard coding your application to do something specific, machine learning would generally learn based on a set of inputs, and then based on the set of outputs create an output. Now, this is one of the most popular fields of AI that is being recently explored, and I believe that it will continue to grow more in the future. And you may have heard of deep learning in the past, and this is more of a complex subset of machine learning that you can use to make to complete more complicated tasks. So some of the applications would be, for image recognition or even stock market analysis, where you can kind of predict how the stock market can move. So what is the process with machine learning? Well, models are trained on data and tested on data that they haven't seen to evaluate their effectiveness. So this means that you train the model with some sort of data, and then you have to test the model on data that you haven't used before in order to see how effective the model is. So the models are the actual programs that do the tasks in machine learning. So they complete the entire process step by step and ensure that the output is what you truly desire. So the type of model that you use is dependent on the task. Now there are various different models for various different tasks, and we can go over about that a little bit more in depth. Well, And as for testing, a lot of testing and application is required to figure out the best method to use for a given problem. So usually when it comes to development, it's not really the smartest idea to settle with one type of model and method. It's generally best to use a variety of models and methods and then compare the results and then pick out which one is your best. So we can see a little bit more of the process here as well. So first, you'd have to retrieve your data, and you have to clean the data as well. You would want to aim for as least amount of noise as possible and ensure that your model can be as effective as possible by cleaning up your data. Then you would want to separate your testing and your training set. So this means is that what this does is that you take an entire data set and you split it into a training set, which would be used to teach your model. And then you would separate it also into a test set, which would be used to evaluate your model. Now you do this once again is so that your model doesn't have bias essentially, and it doesn't evaluate, the accuracy score to be 100%. Because if you were to train and test using the same data set, then your model already knows what is what, if that makes any sense. And then your third step would be to choose a method. So we went over this a little bit more as well. So you would want to typically think about what kind of process that you'd want to use in order to, actually create your model and which type of model that you would actually want to pick out for the problem. And then the fourth step would be obviously training on the training set. So this is where the model actually takes some time to learn about the data that you have given it. Usually when it comes to machine learning, it'll just be simple tasks like separating it into different classifications. And then finally, you would have to test your data in order to evaluate it. So you would give your model some sort of new type of data, and then the model would evaluate this data, and then you can compare how many times it has gotten a certain output correct or a certain output wrong. So the methods of machine learning. So the first method is supervised learning. So supervised learning essentially uses labeled training data and feeds it into the algorithm. And this algorithm learns and develops a model for predicting future values. If the model is tested on unlabeling testing data the model has never seen. And if this is successful, we can use this model to predict unknown labels. And this is called supervised learning, as the labels supervise whether or not the model is accurate. So we can see here is that we have our data consisting of squares and triangles. Now, what we do is that we separate this entire data into two different pieces, and we give it labels. So we're telling the model that these are squares and these are triangles. And then we feed this into the supervised learning algorithm. And then if you were to receive some sort of shape that is unlabeled for testing purposes, so we want to figure out whether the shape is a square or a triangle, we would be able to feed it into the algorithm, and the output would be a square because it matches this set of data closely. So there are various different types of supervised learning algorithms. However, the most popular are linear regression, which basically draws a line of best fit to predict future values. And then you have logistic regression, which is two classes fitted by a logistic curve. Then you have a decision tree, which is basically a yes or no tree to make predictions. And an example of a decision tree is right here. So you can have your outlook, and then there could be three options. So if it's sunny, and then if it's also humid, and then the tree can go on and go on. But however, the point is that you're trying to get to a certain end goal. That is whether or not you should play tennis. So say, for example, if it's sunny and the humidity is high, then you wouldn't play tennis. However, if it's normal, then you would. And then you also have neural networks, which are complex mathematical models made using nodes and weights for many other purposes. Now, this is more complex, but essentially what it does is that it mimics the human brain's learning pattern in order to solve some problems. So you can see here is that there's a picture of a dog, and it gets passed into a node, and it goes through a series of complex mathematical notations and nodes using weights. And then you can finally classify this picture into a dog. So the second type of the process that we have for machine learning is unsupervised learning. And what this does is that it takes unlabeled training data and feeds it into the algorithm. So the algorithm learns and finds a hidden pattern in the data. So outputs are usually the classified inputs, and they're typically used to find hidden patterns in data invisible to humans. And the results sometimes run through experts to make sure the pattern actually found exists. So we can see here is that from rather than from previously, you can see that our data is mixed up and it's unlabeled. So both the squares and the triangles are unlabeled and they're mixed together. So if we were to feed this into a regular machine learning model, we wouldn't be able to tell the difference. However, when it comes to a supervised learning, unsupervised learning algorithm, it usually is able to find some sort of pattern. So whether it be, the 90-degree angle or the four sides, and it splits the data into different labels. So some applications of unsupervised learning would be to categorize news articles automatically. So, it could take the title and it could separate it into technology, sports, or entertainment. You could recognize objects in images or perform a medical diagnosis. So if you were to take an MRI report, you could tell, what problem is which and where it is. And you can find anomalies in a data set or discover data trends for recommendation. So here are two projects that are made by Google, which that we can explore to learn a little bit more about machine learning. So the first is Quick Draw with Google. And so basically, Quick Draw with Google uses a neural network to learn to recognize doodling. So if you were to press draw and it says to draw a goatee, this is kind of hard, but say if you were to draw, a person.
I see necklace, or cup, or face, or calendar. I see smiley face. Oh, I know, it's goatee.
And then so the model is able to predict what you have drawn based on your sketch, and it gets it into an output. And let's say if we were to have a jacket, it would be the same thing.
I see hexagon, or t-shirt, or sweater.
So we can see that, the model makes different predictions each time, but as you were to get more closer.
Oh, I know, it's jacket.
Your final product, it's able to predict. So another thing is also Teachable Machine. So what Teachable Machine does is that it makes it incredibly easy for individuals with no experience within the machine learning field to make a machine learning model. So we can see here is that from the main page, we can create a new project. So we have, we can make an image project, an audio project, or a post project. So say, for example, if we were to do an audio project, you can teach a machine learning model based on 1 second long sounds from files or your microphone, and you can classify that into output. So say, for example, if you wanted to determine whether or not what someone was saying yes or no by strictly using AI, you would be able to do that. And then if you were going to do a post project and see if someone was doing jumping jacks, you can compare the different positions that they would have, and you can see if someone's in a squatting position or jumping up or doing a push-up, etc. All right, so now to the more fun part of this workshop. And please, if anyone has any questions, feel free to put them in the chat. So let's make a small machine learning project that will be really quick. And so we can apply what you have learned with Teachable Machine. So project overview. So what we're going to do is that we're going to learn how to use Google's Teachable Machine in order to essentially train our computer to recognize our own images. So once again, Teachable Machine is a fast and easy way to create machine learning models for your sites, apps, and more with no expertise or coding required. And hey, maybe you can use this within your project as well. So Teachable Machine is a web-based tool that allows machine learning to be accessible by anyone. And what we're going to do is that we're going to create a machine learning model that will classify images. We're going to be applying fundamental machine learning processes of training and testing data without code as a barrier. So first, we're going to go through a walkthrough of the short video to get a feel for Teachable Machine and how it works, and then we'll get started on our own project.
Hi. There seems to be an issue with the video because there's no more volume. If that's yeah.
Do you know of any methods to fix it?
I don't know if is it on our side because the audio was playing for like halfway through the video, and then it stopped.
Okay, I'll try this. Can you hear it now?
Teachable Machine
Yep.
in their own
Perfect.
experiments,
Thank you.
solving problems in their communities.
And samples of your dog. Click Train, and you instantly have your own machine learning model, which you can use in your sites, apps, and more. You can upload your model to host it online, or download it to work entirely on device.
With Teachable Machine, you can create custom models for all sorts of things. Using images, audio, or even poses. Personalized machine learning models for the things that matter to you. And folks have already been trying it out, using Teachable Machine in their own experiments, solving problems in their communities, or even just at home. Start creating and see where your ideas take you at g.co/Teachable Machine.
All right, perfect. So I think that this video kind of summarizes what Teachable Machine is. We kind of got a feel for what how it works. So let's get started with our project. All right, so I see a question in the chat by Prab. Thank you for asking this. So would using a teachable machine instead of something like TensorFlow affect our score? So adding on to what Brandon Joe said, I think not necessarily, because it depends on what you build with it. So in either case, if you build an innovative product, you'll score better. So yeah, definitely, I agree. So there's a variety of things that you can do with Teachable Machine, and a variety of ways that you can actually implement it into your application. Now, if you were also wondering about the accuracy itself, Teachable Machine in fact does use TensorFlow in order to create the model. However, it's more simplified, and you won't be able to do more complex tasks like, say, predicting stock analysis. However, you still would be able to, do image classification or audio classification, etc., to kind of get a feel of machine learning and incorporate like in a small scale for your application where it can still have a large impact. I know one method that this was done in a previous hackathon from long ago was that a group actually made an application where that you would be able to detect garbage and see whether or not it should actually be recycled or kept in the garbage. And one way that they did this was by using Teachable Machine and training it based on, what items are recyclable and what items are meant for the garbage, and treating it as such. And also, you asked if we can use normal images and not from the camera. Yes, we can. And in fact, for this project, we will be using just regular downloaded images and not our webcam. So you'll learn more about that. Perfect. Does anyone have any more questions before we go on? Feel free to raise your hand or put it in the chat. All right, I think everyone is good. All right, moving on. So what we're going to do is that we're going to access Teachable Machine through this link. So what you can do is you can either just search up Teachable Machine on your computer, or I can also post this in the chat. All right, so you can click on that website right over there, and it should take you to the main page of Teachable Machine. So once you've accessed the website, you can click on Get Started, and it'll take you to the main page that I showed you guys a little bit before. And from that, what we're going to be doing today is an image project. So you can click on image project. And we'll just be using the standard image model for today, which has 224 by 224 pixel colored images. And you can export your model to either TensorFlow, TensorFlow Lite, and TensorFlow.javascript. So, and then the model size would be around 5 megabytes. So as we can see here is our main page. And so we have our class, a way for us to add our image samples, and then our second class and our second set of image samples. And then this would be used to train the model, and then we can preview it afterwards. So today we are going to be using this data set in order to compare cars and bikes. So I can post a link in the chat here as well. If you guys have worked with Kaggle before, you should be able to access the data set. If not, I'm afraid that you might have to make an account. However, if anyone has any trouble with that, please let me know and I can help you sort it out. Out of curiosity, is there a website that is dedicated for data sets? Yes, so there are in fact multiple websites that you can use, but the most notable would be Kaggle. So here, there's lots of stuff that you can do. But to answer your question, they have an entire page on data sets created by the community. So, you can see home loan approval data sets or Bitcoin rates, Ukraine war statistics, or something that I did recently was with Microsoft stock. So I was able to, use the past 6 years worth of Microsoft stock as my data set. And you could, use a variety of data sets for a variety of different problems. And yeah, it's really nice to have something like this, because if not, then you would have to create your own data sets and, go, find different sources and make sure that's all accurate. But this just makes life incredibly easier, and it allows you to get started immediately. When it comes to real world applications, if you're working for a company, either you would have to use, the company statistics, given to you by, the statistics team, or, sometimes you would have to go and seek out this data yourself. That's why you see many companies, collecting data from their users or from surveys, etc., so that they can use the data and feed it into a model to provide better analytics or recommendation systems. So we'll be using this car versus bike data set, and it should look like this. And then you can always see a little bit more about the data set. So this data set is a collection of 2,000 bike and car images, and then it was made sure that all types of bikes and cars are included in the image collection. So all you would have to do is download the data set. I've already downloaded it, and you'll just have to open the zip file. So once you guys have, has everyone done that? Is anyone having any issues? All right, I'll take that as good for everybody. So we'll move on. All right, so what you'd want to do is that you would want to locate your data set on your computer. Most likely it would be in your downloads, and then you can just access your data set from there. You should see 2 folders, whether you're on Mac or Windows or Linux, and it should be a bike and a car. So next, perfect. So next, you'd want to go into your Teachable Machine, and you'd want to create your 2 classes. So in this case, I'll make it class 1 could just be my car, and class 1 could just be my bike. And then you would want to upload your data. So what you can do is that you can see that for adding image samples, we're not going to be using the webcam today. We'll be using the upload function. So what you can do is that you can click upload, and then you can choose images from your files or drag and drop. And so when you do choose images from your files, you should be able to access your car data sets. And what you'd want to do is that you basically just want to select all of your images, open it up, and it would load all of the samples in here. So it's collecting all 2,000 images, and it's feeding it to the model, and it's in fact, setting it up so that you can eventually train your model. So we can see here, all 2000 images are now being loaded and ready and being labeled under a car. So can anyone be able to just put in the chat what type of model that we're using? Would this be supervised or unsupervised? You guys can raise your hand. Perfect. Samantha King put supervised. Perfect. Yep, you're correct. So it would be a supervised model because you are taking all of these images of the car, of the cars, and you're labeling it as a car for your model to then use and learn from. And then we can do the same thing for the bike. So we can choose images from our thing, from our downloads. And instead, now this time we'll be passing all of our bike images. And then once we've selected all of our bike images, we can then add it over. So this essentially is repeating the same process. You are, getting all of your downloaded bike images and you're passing it through the model, and now it's being labeled as bike. So now, so that your model can differentiate whether a certain image is a car or whether a certain image is a bike. Seems like it's done. So now we can move on to training the model. This is going to be a form of deep learning. You would use a CNN for this, and that is more complex. However, it allows for images to be either recognized or classified, and you can essentially train for image recognition or classification in order to solve a problem like this in a case where you would have to differentiate between a bike or a car. So what we can do is that we can press the train model, and it's going to prepare our training data and it's going to train the model. So now usually training the model takes a while because you would have to pass about 4,000 data samples, because 2,000 from the car and 2,000 from the bike. Okay, it appears to be unresponsive. Let's try again. Okay, troubleshooting here. Let's retry. All right, does anyone have any questions so far in the meantime? All right, I'll take that as a note. All right, so do the images need to be processed for better results? So usually the more clear that your images are, the more better that your results would be, because it would be much easier to identify, what image that you're presenting to the model. However, in some cases, you would actually have to implement image manipulation techniques in which you would actually have to either, reduce the quality of the image or stretch it or turn it into grayscale or whatnot in order for the model to more accurately learn. So say if you wanted to differentiate between, a cat and a dog. So one way that you would be able to do this is that you can reduce the quality of the picture, and you could essentially gain an outline of the image like in the center. And using this, so say if the image has pointy ears rather than ears that are flat and off to the side of the face, you can be able to determine whether or not, what you're passing through the model is either a cat or a dog. And as for passing in the images, like the more images that you do feed your model, the better it is, because your model will have more data sets to work with and actually be able to find a better pattern and more accurately be able to tell whether something is, in this example, a car or a bike. So as opposed to 2,000 image samples, if we had 5,000, it would be much better. However, it comes with the cost of time, and that's not something that a lot of people have, essentially. So you typically want to aim for a balance in which that you're being time efficient, but also being accurate as possible. Does that answer your question? Perfect. Okay, so let's try training the model again. And we can go into the advanced tab after. I can explain to you, but for now, we'll just keep it at the default and we'll train the model. So training the model usually, once again, takes a long time because you'd have to work with 4,000 image samples. And let's just hope that it works this time. Let's see. How many images per class would you say is ideal in general? So it depends on basically like the accuracy score that you're aiming for. Obviously, in most cases, you'll never be able to get 100% accuracy score, but you would at least want to aim like to the 70 to 80% range. And for that, I feel like most of the data sets within Kaggle have like a sufficient amount in order for you to actually train your model with high accuracy. So for this example, you have 4,000 images, 2,000 of them being cars and 2,000 of them being bikes. So for this, I would say that 2,000 images would be ideal. And in most cases, I would say if I were to give a range, typically around like 1,500 to maybe 3,000. And once again, like if time isn't a problem at all, and you can wait all day long for your model to train and know, then obviously the more images that you have would be better. But trust me, when you get to with bigger data and bigger sets of data, if you have a lot to process, it'll take a lot of time. And in cases where you're doing, you need to crunch down on a hackathon and create a model, or if you need it to for a job, or just for like a passion project that you want to get completed by the weekend, typically you'd want to have a smaller sample. But as for image recognition, I'd say at least from like 1,000 to 3,000 max for ideally. Okay, so the model actually trained pretty fast. When I did it initially, it took around 5 minutes. But as we can see here that the model has trained, and I hope that your guys' models has finished training as well. And we can see here, just moving on. So this repeats, let's just go through the process. So once again, you just want to update the classes, upload your data, so you can select all the files, and then you just want to wait for your data set to upload and repeat for the other class. And then you can train your model, and then it can take some time to train. And then once your model is done, you can test your model. So as our model is done, we can now test it. And instead of using our webcam as our input, we're just gonna have a file. So I'm just gonna choose some pictures that I just downloaded earlier. So say if we wanted to include a picture of a car, we can see here is that this car is set to be 98% of a car and about 2% of a bike. And that's because this is more of a rear view. And it's something that our model might not be extensively trained on, as you can see here from the beginning pictures. Most of it is either a side or a frontal view rather than a rear view. And then we can also place another image of a car, say a Mercedes-Benz, and we can see here is that we get 100% accuracy that this is in fact a car. So we can do the same with bike images. So I can just save this as bike. And if you're wondering, the name, the name for any image that you test your model on has no impact on the output. But as you can see here is that the output for this image is 100% a bike, because all the images that because this image is 100% similar to all of these images that we have passed here. Now, let's see what happens if we were to pass in something as a cat image. So cat image. We can just take this photo. So this cat. And we can pass in this. So we can see that we get 98% car. I'm not sure why, but our model thinks that this is 98% like a car because it's most similar to these pictures up here and not these. Obviously, this would be incorrect. And if we were to train another class specifically on cats, then it would recognize this to be a cat and not a car. And moving on. You can find any images to test, and it could be any image once again. And you can enjoy your model. So now you have successfully made a machine learning model that can differentiate between a car and a bike. Congratulations. Now, if you wanted to export this model, what you would have to do is you can just click on export model here at the top, and you can see a variety of code that you can use. So say if I wanted to use TensorFlow for Python, then what I can do is that I can take this, I can download my model, and then what I would do is that I could just copy and paste this into my code, and my model would work within my code. So you're saving a lot of time and a lot of thinking if you're new to the machine learning area when it comes to, say, image classification, and you could just you can create something in seconds. And that's about it. And so this is here. So they have two types as well. So if you're using Keras or if you're using OpenCV Keras, and it would be the same thing. OpenCV Keras would be for if you're using a live webcam. So say if you had a pet cat and you wanted to hold it up in the air in front of your web camera in order for it to detect, then you can do that as well. Perfect. Does anyone have any questions? All right, I'll take that as a no. So now we're just going on to a little bit more of a bonus section. So I said that I'll cover the advanced section afterwards, and I'll do that. But before, which way of exporting is the most beginner friendly? So there's not really, a specific beginner friendly method. It's more of just what suits your model. So you can see here is that, so say if you wanted to use, JavaScript and include your model on, a website, then you'd be able to do that using, this JavaScript code. Obviously, you'd have to know where to put it, and that's the hard part, as it kind of differentiates. But as for importing the model, it's just downloading the model, copying the code, changing some of the code here. So say from Keras.models import load model, you would just put the model that you have, and say for image path, you would replace it to the path of your image, etc. But as for that, like all methods should be easy. And even here, you can do it for Android as well, for example. And if you're using, I think, Android Studio, and then you can import your model there too. So like there are steps, and I'm pretty sure if you were to use Stack Overflow or any other coding resource, you would also be able to find more tips on how to actually implement the model. But I feel like all methods are straightforward, beginner friendly, because when it comes to actually creating the model, this would be, if you're doing this from scratch, this would be a really complicated task, as you'd have to pre-process, clean up your data, label everything, and then pass it on into your model that you yourself would actually have to create. And this does everything for you, and you just have to export it, copy it down, and it should work without an issue. Does that understand? Perfect. All right, so let's move on to the bonus section and we'll cover the advanced section. So what these are called are, these are hyperparameters. And hyperparameters basically dictate the governing process of your model. So it basically, determines how your model works, and whether you, and by changing your hyperparameters, you can either get your model to perform worse, or you can either get your model to perform much better. So we can go through each one of these hyperparameters that we have, and go on from that. And you can also, if you're doing this on your own, you can hover over the question mark here to learn more. So first we have epochs, and this is set to base 50. So one epoch means that each and every sample in the training set has been fed through the training model at least once. So what this means is that you're taking this image and you're passing it through the entire model once, and that would be an epoch. So if you were to have, if your epochs were to be set to 50, for example, it would mean that the model you are training through will work through the entire training data set 50 times. And generally, the larger the number, the better your model will learn to predict data. And you'd probably want to increase this number, as it says here, until you get good predictive results with your model. So basically what happens is that you take, all of these images and you pass it back and forth from your model. And this allows your model to, constantly learn and be able to, formally dictate which is a car and which is a bike much better, as opposed to, having one set of images. And generally, the more epochs that you have are better, because your model is able to learn more. And however, it also comes at the cost of time efficiency, as it takes a large amount of time, to move 2,000 images back and forth from a model. And especially, doing that 100 or 1,000 times will take, trust me, a very long time. So next we have a batch size. So a batch is a set of samples used in one iteration of training. So it's basically, is the amount of samples that you're using for one set of training. So say if you were to have 80 images and you choose a batch size of 16, so this means that your model will have 5 batches, because 80 divided by 16 is 5. So once all 5 batches have been fed through the model, exactly 1 epoch will be complete. So say for your 80 images, you create a 16 batch size. So only when those, and you were to have 5 batches, because 16 times 5 is equal to 80. And only once all 5 of those batches have been fed through the model, 1 epoch will be complete. And it says here, generally, you won't need to tweak this number to get good training results. However, if you would like, you can play around with it and see what works best for your model. Typically, when it comes to machine learning, it's always best to experiment with hyperparameter. And one main aspect of machine learning is actually hyperparameter tuning, in which you actually create multiple models with various hyperparameters to see which one performs the best. And then you take the one that has the most accurate results as your best machine learning model. And we can see here learning rate, and it says to be careful tweaking this number, as even small differences can have huge effects on how well your model learns. And I would say that this is pretty accurate. So learning rate basically describes the rate at which your model learns, right? It's self-explanatory, and it kind of just determines like how fast your model learns, and the types of patterns that it's able to understand and get. And by tweaking even a learning, by tweaking the learning rate, obviously your model can get better or it can get worse, but you would have to be careful, as either tweaking it too much might lead to disastrous results, or tweaking it in the right way just might be perfect in order for you to get to that high percentage. Does anyone have any questions? All right, so I'll take that as a no. Perfect. Yeah, this is extremely cool. But yeah, let's see. So you can also click under the hood. I'll go through the slides first. So you can use this button to learn more about how the machine learning model works, if you're ever interested in it, and if you ever want to go more in depth about what's happening behind the scenes. So they have a little bit of vocabulary here that you can use, and it's okay if you don't understand. When I started my machine learning journey, which is not over even a year ago, I was pretty lost. But with more practice, consistency, and effort, you should be able to become a pro in a matter of at least like a year. So we can see that our teachable machine splits our samples into 2 buckets, and that's why you see 2 labels in training and test. So 85% of the samples that we provided are used as training samples, and then 15 is used for testing. So what happens is that we're training our model based on 85% of the data, and then we're also, before we test it here, we're also internally testing our model to see how well it performs. And we have some more machine learning concepts. So underfitting a model and overfitting a model. I'm not going to, I guess I can explain this. So underfitting the model is when it classifies poorly because the model hasn't captured the complexity of the training samples. So it's basically is that you haven't provided enough data for the model to actually understand, the differences, say, between a car and a bike. And overfitting a model is when a model is fed too much data to the point where it can only classify the training samples and can't make correct classifications on test samples. So this may not be more prevalent with images. However, what happens is that, say, if you were to only train your car data set based on one type of car, so let's just say like a Toyota Camry or something, right? Your model will then only be able to know if something is a car based on if it looks like exactly like a Toyota Camry. However, say if you were to give it, a Mercedes Benz or something, it wouldn't be able to accurately know that that's a car, rather and classify it that way. That's one example of overfitting, where your training samples match it too closely and it can't be used in the real world. And then we went over epochs, and then you can also see your accuracy per class and confusion matrix. I won't go through this, and then it's just more calculations. However, if you were to be creating your model right now for your hackathon, for example, you wouldn't need to know this. You wouldn't need to know all of this. However, just knowing just the general vocabulary and how your model can be affected, I guess, would be important. And all right, so we went over exporting the model, and you guys can feel free to try it yourself, play around with it. There's lots of things that you can do. Machine learning is a wide field, and you're not only limited to stock analysis. No, sorry, not stock analysis, for image classification. In fact, I can show you guys quickly one small project that I made on the side. And let's see here. Okay, so this, I'm trying not to feel overwhelmed because Teachable Machine is much more simple. But this is an example of actually using Keras to create a machine learning model. And what this model does is that it takes Microsoft stock from 2015 all the way to 2021. And it kind of creates, something that you can use to predict Microsoft closing price. Right, so you can see an image of the closing price that you have with Microsoft, and then after making some code, same kind of process. So what you would want to do is build your model, you train the model, you test it, and you would reshape the data, evaluate it, and by plotting, you can see that through AI you can predict actually Microsoft stock. So you can see that it's not completely accurate, and that's obviously because you might need more data, or there could be an error within the code, something that I might have missed. But you can see here that it typically performs to do well and kind of mimics the pattern of the stock itself, and it does pretty good for itself. So this is also another way that you can learn machine learning. So what are the requirements to get to that level of machine learning? Do I need to know calculus and linear algebra? What else? So definitely calculus and linear algebra would help for general things. If your school has, a statistics course, that might be something that you don't want to get into as well. A lot of entry-level statistics is used in machine learning concepts, something like linear regression that we talked about, which is basically creating a line of best fit. That's something that you actually cover in grade 12 statistics, so it might be interesting. For generally, I would say that for stuff like this, which is like on the lower level of advanced, I would say, it generally doesn't require a lot of math unless you want to dig down deep. However, if you just kind of want to just, write the code, understand how it somewhat works, and deal with it from that perspective, you should be able to, just get by knowing, basic level math with just a little bit more, and, like with a little bit more research and practice and just a little bit, tiny bit more of knowledge. However, like for the most part, like you can get by with just like, simple level, like grade 11, grade 12 mathematics, and you can be doing so much with machine learning already. However, I know that when you do get into like the more complex stuff, what's an example? So say if you wanted to do audio recognition, I think that uses, more complex math, or if you had to, analyze your data more in a specific way, etc., it would typically require higher level understandings. However, like that's only specifically if you want to understand like every single possible way in which your model would work, rather than to actually implementing it. I feel like implementing the model, it takes less mathematics to understand, like when it comes to writing the code. However, if you're interested in how the model works and how it performs, you typically would need to have a higher level understanding. However, but yeah, high school math can get you pretty far when it comes to learning, the basics and a little more intermediate and advanced. No problem. Does anyone have any other questions? All right, I'll take that as a no. All right, so then if that's all, I'd like to thank everyone for coming to this workshop. It's nice been explaining to you all about the introduction to artificial intelligence and how to also make a machine learning model using Teachable Machine. I really hope that you guys did test it out and maybe implement it into your app idea, because that would be really cool, and something that when I did hackathons in the past, wish that I would have been able to do it as well. If anyone has any questions, feel free to, I guess, get my email from Brandon. You can ask any questions. I can also post my LinkedIn in the chat if anyone wants to connect with me. And if you guys have any questions or, need some advice on machine learning, I'd be more than happy to help. And that's all. And more than honored. Thank you guys for having me. And yeah.
And thank you for hosting. We really appreciate it. And yeah, if any one of you wants to reach out to me about whether you want an email, or if you want, if you're okay with sending your slides too, we can share that with the participants. And yeah, thank you very much. We really appreciate it.
Perfect, no worries.
And also just one more thing, would you be okay with us posting this on our YouTube for anyone who may have missed the workshop?
Yeah, for sure, go ahead.
Sounds good, thank you.
Perfect. Thank you. Thank you guys for participating, making this workshop great. I really hope that you guys use artificial intelligence. But for now, I'm out. Happy hacking, everyone.